let's get stuck into it because there's quite a lot. Now, I looked at the first question, and this one's a difficult one. So I'm actually going to skip this one and go to the second. We'll come back to the first question. All right. We'll do this one first, and then we'll come back to the other one because I feel like the other one's more difficult. You know me, I like to leave the good stuff for the end, all right, of the lesson. Just when you guys are tired and ready to go, then I hit you with the hard one. All right, let's try this question first. So it says here we have a circular concrete slab. It's planned for an outdoor picnic area. The circular concrete slab will be surrounded by bricks along the perimeter as follows. Please note the drawings are not to scale. Okay, so we've got a top view there on the left of what the concrete slab looks like. And then we've got a side view here on the right, a cross section of the slab. We can see the blue bricks there, and we can see the gray concrete slab. And underneath is obviously the ground. We also have dimensions of a brick. If they give you dimensions like that on a brick, you probably need to use them. But all our information is there on the diagram. Okay. Just looking at the diagram there, I don't know if you noticed, but we can see we've got centimeters here, we got meters over here, and then we got centimeters here. So just check the dimension, the unit, sorry. We might need to change one or two of them. But there is all the information on the diagram. So let's go down to the first question. Nice and easy. Start off nice and slow. Convert 520 centimeters to meters. Come on now, everyone should be posting in chat with the answers. Don't even need a calculator for that. Come on now, what is 520 centimeters converted to meters? Everybody could be doing that in their heads. You know what to do. Yes, the answers should come through thick and fast. Yes. All right, good. So 520 divided by 100, that gives us 5,2. So that dimension on the drawing is 5,2. All right, don't forget that. Moving on to the next question. Use the following equation to calculate the volume of the concrete in the circular concrete slab. Answer in meters cubed, and they give us pi 3,142. They give us a formula. Now, what do they mean by volume? It looks like just a circular disc. Well, this is a cylinder shape, all right? There's a circular disc, and if you give it height, it then has volume. All right, so a circle with height has volume, doesn't it? Yes, everyone knows that 520 centimeters is 5.2 meters. Good. So we need to calculate the volume of this concrete slab. They want it in meters cubed, which is why question 1 said convert the centimeters into meters. All right, so here we go. I will tell you, I'll draw a little diagram on the right here. We had a circle with a line going through, and it was 5,2 meters we've just discovered. And the height of the slab, I'm going to draw a little arrow here. Let's just do this. My drawing is horrible tonight. Okay, so this thickness of the concrete, or the height of the concrete here from the drawing, 0,15. 0,15 meters. Okay, so what is the volume? We've done this so many times now. What is the volume? You work it out. Excuse me, it shouldn't take you long. Note this is a 4-mark question. You might be asking yourself, 4 marks just for putting in some numbers into a formula. Why 4 marks? But the other dimensions on the right-hand side, I've drawn it in there for you. It comes straight from the diagram. What is the volume? Tando, we're going to use this formula here for volume of a cylinder. Pi times radius squared times height. So they say use this formula for volume of a cylinder. All right, there it is there on the screen. All right, Pumlele's already got an answer out. Getting different meters squared. Bianca, meters squared. We're getting different answers now. Aura's getting a different one to Lufune. Safiso's also getting a different one. I love it. I love it when we get different answers. Yes, Michael, don't stress. Don't stress, don't stress, don't stress. Okay. Don't stress. Ben's getting 3,19. Looks like Ben's rounding off. Good job. Getting different answers. I love it. I love it. It's all right. We're all making mistakes. Sally's getting an answer there. Eyeball's got an answer there. All right. Different answers. Woo, I love it. All right. Kagiso's got a question. Yes, Kagiso.
Good evening.
Evening. How are you?
I'm getting yourself.
Good. Are you warm? Is it cold there?
It's okay. It's not a problem.
What's okay? My okay
But
is like
it's
22.
a bit windy. It's a bit windy, but you'll be fine if you wear a jacket, like that type of weather.
I wear jackets when it's like 19 degrees. Now, what's okay for you? What's okay for you is not okay for me.
Serious.
How many degrees you got there?
Let me check. It's 16.
Okay,
16
yeah.
degrees.
All right. Yeah, I mean, for you, that's okay, but 16 sounds cold to me. But anyway, you had a question.
Serious.
I come
Okay.
from Durban. I come
So,
from Durban. Yeah. I feel embarrassed now.
okay, yeah, that's understandable. So I said 5.2 meters divided by 2. Is that okay?
You
Before
must, because
squaring it.
yes, you must, because that dimension they gave us there is not a radius, it's a diameter. Good. So the
Yes.
five,
So
good. The 5,2 must be divided by 2. That'll be the radius. Good.
it gave me 3.18. That's why, yeah.
The answer.
Yes.
All right, let me put it all in here. So we got pi there on the left, 3,142. I took my
Times.
diameter, which is 5,2, and I halved it to get the radius, and that must be
It's going to give you
squared.
3.6.
And the height
That's
is
to give you
0,1.
2.6.
All right, let's check it out. Let's check it out. I'm going to chuck it into my calculator here, 3,142 times, I'm going to put all my bits and pieces in. All right, I'm going to use a bracket here. Okay, so I'm going to put my 5,2, cut it in half. Why am I cutting it in half? Because I need a radius, not a diameter.
Because
They
you need a
gave us a
radius. So
diameter. Yeah, I need it squared as well, and I need to multiply that by the height,
that's
0,1.
0.15.
All right, let's check it out. There we go. There you go. All right, so 3,1859. I'm going to write it out here.
Yes.
3,1859, which becomes 3,
1.8.
careful,
3.17.
it's that 8 there, the second decimal is an 8, but it's got a
Yes,
5
it's 8,
next to
right.
it. So that
It's
8 will
9.
become a 9. All right, I
That's
saw
7.
Ben there. Saw Ben rounding off there. Yes, good. So that's 3,19 meters cubed.
Oh,
All right, excellent.
9.
Yes, excellent. Good job. Thank you very much. Thanks for reminding us that the diameter must be halved, must become a radius. Awesome. Thanks, Kagiso.
You're welcome.
All right. All right, all right, all right. Yes, I saw Ben. I think it was the first one that did it with the rounding. Dividing. Good question. Yes. So, why are we dividing by 2? Yes. Hold on. There we go. There we go. Let's talk about it. Isona, you there?
Yes. Can I ask why are you dividing 5,2?
Good question. Very good question. That's the first thing that Kagiso said. She said, "Sir, make sure that you divide by 2." So you'll see here the formula says radius. Yes, it needs a
Yes.
radius. And in our circle, is this line here a radius or a diameter?
Yes.
Is it a radius or diameter, that blue line in our diagram?
It's a diameter.
Yes. So the diameter must be cut in half to get the radius, yes?
Yes.
So that's why we're dividing the 5,2, the diameter. We must cut it in half, divide it by 2.
Okay. Thank
All
you.
right. No problem. All right. So we divided the diameter by 2. Okay. So there we go. There's our volume of our concrete slab. Guys, We doing volume questions like it's nothing. All right. So we run off. We were told. In the exam, we always trying to teach the exam. So in the exam, the instruction on the cover page will be every time round off to 2 decimal places unless told otherwise. So unless the question says something else, we always rounding off to 2 decimal places. Always. Okay. Only at the end of the question. Only at the end of the question. All right. Don't round off before the end of the question. All right. So there's our volume. There's our volume there. Next question. Let's see. Come on now. Oh, guys, now it gets real. Whee! Well, first, let's take a question here from Oratile. Yes, Oratile. Oh, sorry. I muted you again. Sorry. Check your screen again, Oratile. I muted. There we go.
Hi,
Hi, how are you?
good and you?
Good. Are you cold?
Yes.
Yes, me too. All right. Yes. What's your question?
I wanted to ask because, okay, from what I was taught and what my previous teacher told me is that if I had a 3,151, if I had 3,185, the next unit being the 8 wouldn't change, meaning my answer would still stay as 3,18. So
Okay.
how are we converting it to 3,19?
Okay. So when you round off, I'll write the number again. So 3,185. Okay. And we're looking at the second decimal to see if it changes. All right. So there's one number there. And then above it, I'm going to write another number, 3,184. All right. So there's two numbers, 3,184, 3,185. Now, when do we change the 8s? So when it's 5 or more. So you see this number that's next to the second decimal. If that number is 5 or more, you've got to change it up to a 9. If it's 4 or less, you leave it. Okay.
Okay, because I thought it was when it's 5 or less, that's when I should just leave it as it is.
Okay, so it's 4 or less, you leave it. 5 or more, change it.
Okay, thank you.
No problem, no problem. Okay, awesome, guys. Great questions tonight. Fantastic, I love it. Okay, moving on to the next part. There's a lot going on here. All right, so 2.4. In order to make concrete for a slab, the cement is mixed with sand and stone. We know that. That's easy. Okay, so there we have a diagram. All right, we've got cement. There's a 50 kg bag of cement, one bag. Then we got a wheelbarrow, and it says 1 1/4. I don't know if you can see it. It's 1 1/4 wheelbarrows of sand. All right. And then the stone on the right, there's a wheelbarrow on the right here. It's also 1 1/4 wheelbarrows of stone. Okay, so I'll put here sand, stone. All right, on the left, we got cement. Okay, so with cement, one bag of cement, you need 1 1/4 wheelbarrows of sand, and you also need 1 1/4 wheelbarrows of stone to make the concrete. You mix it together, it makes concrete, and then you pour the concrete. All right, we know that. Okay, so let's see why they're telling us this thing now. Oh, guys, get ready. Next question. 1 cubic meter of concrete needs 7.7 bags of cement. Here comes the question. 1 cubic meter of concrete needs 7.7 bags of cement. Here's the question. How many bags for our, what are they calling it? They're calling it a slab for a picnic. All right. So how many bags for our slab? Okay. Now, there's the question. I'm going to bring in the answer. This answer here, I'm going to bring it down. Okay. You're going to need it. All right. So our concrete slab needs 3,19 cubic meters of concrete. The question says 1 cubic meter of concrete needs 7.7 bags of cement. How many bags for our slab? That's the question. How many bags for our slab? $3.4. 2.4. All right, so there's the diagram. Okay, and all I've done is I've brought in the volume of concrete that we need for this slab, and they tell us that 1 cubic meter of concrete, you require 7.7 bags of cement. So how many bags of cement for our slab? How many bags of cement for our slab? If 1 cubic meter of concrete needs 7.7 bags, and our concrete is 3.19 cubic meters, how many bags for our slab? Okay, let's see. Let's see. Let's see. Let's see. We're getting answers here. Oh, getting answers. Yes, yes, yes. Good, good, good. All right, good. All kinds of different answers. I love it. It looks like is basically you need 25 bags. All right, let's check it out. Let's check it out. All right. We've got 3.19 cubic meters of concrete to take care of. All right, we've got 3.19 cubic meters. Okay. All right, every one of those is 7.7 bags. We're going to multiply by 7.7. Let's see what we get. So 3.19 times 7.7 equals 24.563. 24.563. Now, you notice people are saying you need 25 bags. Okay. Why they're making it a whole number? Because we're assuming that when you buy these bags, you can't buy 0.563 of a bag. So yes, I totally understand if you guys say make it 25 bags. I totally get it. Absolutely. I would also buy 25 bags for this job, because you can't buy 0.563 of a bag. You have to buy another bag. So it's 25 bags. My question to you, this is correct, 25 bags. My question to you is, what if, I'm going to put this back just now, what if the answer was 24.163? How many bags do we need? What if the answer was 24.163? How many bags do we need? Some people saying 24, some people saying 25. Okay, who wants to come tell me, raise your hand and tell me why you're saying 25? Somebody raise their hand and tell me why you're saying 25. We got people saying 24 and people saying 25. Normally you look at that number and round down to 24. Why are people saying 25? Raise your hand. Raise your hand and talk to me. Explain to us, why would you say 25? Nothing wrong with it. I'm just wanting an explanation for the 25, that's all. Which brave soul? Anybody? Avila. All right, Avila there. I
Just
saw
look
Avila
on
there.
your screen for a message that's gonna ask you to unmute. There we go.
Avila?
Okay, hi sir.
All right, how are
Hi
you?
sir.
I'm going to ask
Good
you the
to
same
meet you,
question.
sir.
I'm good, thank you. I'm going to ask you the same question. Are you cold there?
Yes, sir. It Loki is cold. I even got a flu.
It's not fun, eh? It's not fun. I'm ready for summer now. Come on. All right, tell us. Why did you say
Okay, so-
25? Why did you say 25 and not run down to 24?
So I think it's because, right, if you're going to use 24, there's going to be a remainder. So you might as well like buy a new bag, sir.
Yeah, very good. If you buy 24 bags, you're still going to need some more, aren't you? This 163, what are you going to do about that? Exactly. So don't round down for this job, because if you say, for example, it wasn't so obvious. You're absolutely right, young man. What if it wasn't so obvious? What if it was 24.4?
Yes, sir. That's why I said 25.
Yeah, absolutely. You're absolutely right. Well done. So what if it's 24.4 and you say, no, go down to 24 bags? This 0.463 of concrete that needs to be made still. Are you going to just leave that out? You can't leave that out if you want to do this job. All right. If you are in the construction industry and you do this sum and you say go down to 24, you're going to be short. All right. So in this scenario, in this context, when you're trying to work out how many cans of paint, how many bags of cement, how many boxes of things do I need to buy to complete this task, don't round down. Okay. I know you're thinking, sir, you just said rounding off, you know, always round off. That's rounding off. Okay. Rounding off is different to rounding to complete the job. Okay. We need to complete the job. So we can't round down to 24. We won't have enough. So we have to, in this case, go up to 25. Always rounding up, no matter how small that decimal is. Go up. Okay. Because you're going to need enough for the job. And if you go down to 24, you will not have enough for the job. All right. Good. Ben, I'm sure you were going to say the same thing. So we need 25 bags. Even if the decimal was 24, sorry, 24,4, we still need enough. All right. But it wasn't 24,4, it was 24,5. Made it easier for us to round up. Please remember that you need enough to complete the job. Okay. All right. Let's look at the next question. Is everyone okay out there? 3,19 cubic meters times 7.7. All right, cool, no problem. So the question says 1 cubic meter of concrete will need 7.7 bags. Well, I don't have 1 cubic meter. I have 3,9 of them. All right, if one cubic meter needs 7,7, then how many bags for 3,19? I need to multiply. For example, if one person eats 2 pieces of toast for breakfast, how many pieces of toast will 3 people eat? You need to multiply. 3 times 2 will give you 6. Okay, it's the same situation. All right, so we have to multiply that. The 3,19 cubic meters comes from a previous question. They asked us to work out the volume of concrete in the slab. That's this question over here. We've already worked that out. So we're using that 3,19 cubic meters down here in this question. All right. Okay, guys, let's move on. Woo! 2.5. Calculate how many bags of cement, wheelbarrows of sand, and wheelbarrows of stone are required for the concrete. Okay, now we've got bags of cement. Okay, we've got bags of cement. I'm going to write you here 25 bags. So I know that already. But we need to work out wheelbarrows of sand and wheelbarrows of stone. Now, if you remember, I'll go up to the diagram again. For 1 bag, you need 1¼ wheelbarrows of sand and 1¼ wheelbarrows of stone. Okay, remember that, please. So each bag, you need 1¼ stone and 1¼ sand. All right. So now the question is, how many wheelbarrows of sand and stone do you need for this 25 bags? Come on now.
Good day, sir.
Hold on a second. Tando, is that you?
Yes, sir. How are you, sir?
I'm good. I'm very good. How are you?
I'm good, sir.
I can bet.
I want to ask.
Yeah.
I want to ask you, how did you get 25 bags?
All right. I'll come back up to that now. While everyone else is trying to work out how many wheelbarrows of sand and stone we need, I'll come back up here. So if we look at the sum that I'm doing here, they say 1 cubic meter of concrete needs 7.7 bags. Well, we have 3,19 cubic meters of concrete. So I'm going to say 3,19 times 7,7, all right, which gives us 24,563 bags that we need. But if you go to the shop, you'll never be able to buy 0.563 of a bag of cement. If you go to the shop there and you tell the person, hey, I need 0.56 of a bag of cement, they're just going to laugh at you. You can never buy 0.56 of a bag. You have to buy whole bags. So we round this up to 25 bags. Okay, and then we'll have enough bags for the job.
Okay.
Okay,
Okay. Thanks, sir.
no problem.
Thank you.
All right. Okay, it looks like we're getting some answers already. It says I'm playing music here. Are you guys hearing music?
No, not at all.
Oh, it's asking me if I'm playing music. Maybe, oh, because I was humming. I was going, "Na, na, 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 na," and it's saying, are you playing
Oh,
music?
makes sense. Makes
Yeah.
sense.
Yeah, it's trying to change the settings for music. Oh my gosh. All right. Looks like we're getting some answers out. Good, good, good. Okay, these are wheelbarrows, hey? How many wheelbarrows? How many wheelbarrows do we need? How many wheelbarrows do we need? All right, so let's have a look. I've got there written there, 1 bag of cement needs 1 1/4 sand, 1 1/4 wheelbarrows of sand, and 1 1/4 wheelbarrows of stone. So let's do the sand first. Check your answers when we do this. All right, we need 25 times 1 1/4. All right, 1 1/4, you guys all know is 1,25. All right. I need to do that. And then for the stone, I need to do the same thing. 25 times 1,25. Okay. And you guys are getting answers there already. So I'm going to say 25 times 1.25 equals 31,25. 31,25 wheelbarrows. I think we should round that up to 32. Then we'll have enough. And we need 31,25 wheelbarrows of stone. And I think we should go up to 32. Why am I rounding up to whole numbers? Because you can't tell the guy at the shop, please give me 0.25 of a wheelbarrow. All right, they're not going to pour stone into the wheelbarrow and then like ask themselves, oh, is this 0.25? You can't do that in a shop. You can't buy 0.56 of a bag of cement. You can't buy 0.25 of a wheelbarrow of sand. It's the same idea. All right. So with all this information, we'll have enough wheelbarrows. Someone's saying, sir, you need to write there wheelbarrows. Yes. All right, wheelbarrows. Right there, 32 wheelbarrows. Okay. I'm going to cheat and just copy and put it here. All right, good. So we need 32 wheelbarrows of sand and 32. Luyanda, good question. Exactly the same as the cement. Okay. So when you, for example, let's say you're making a cake and flour comes in a 1 kg bag, right? Let's say 1 kg bag of flour is on the shelf. You need 0.82 kilograms of flour. You only need 0.82 kilograms of flour for your cake. You can't take the bag off the shelf, pour some out until you have 0.82 kilograms. You can only buy a 1 kg bag. Okay. So when you go to shops and you buy quantities of materials in units like bags or buckets or tins or wheelbarrows or cases, all right, you can't take some out so that you have exactly 0.82 of a kilogram flour. You have to buy the whole bag. All right. So when they ask you, how many bags do you need? How many wheelbarrows do you need? How many tins of paint do you need? You can't show decimal places for this, first of all. Right. Secondly, why did I go to 32 if it says 0.25? Again, if I say 31 wheelbarrows of sand, I won't have enough sand. I'll need more because I need 31,25. I need 31 wheelbarrows and a quarter of a wheelbarrow. If I say, no, just give me 31, I'm still missing a quarter of a wheelbarrow of sand. I won't have enough for the job. So in this case, don't round down to 31. Round up to have enough for the job. So let me write that in red here. You need enough for the job. You need enough for the job. You need enough for the recipe. Okay, so when they ask you to make a recipe or do a job or complete a task, you need to have enough to complete the task. All right. Don't chop those decimals off and say, I'm rounding down, because you won't have enough to complete the task. Okay. So there's a certain case where we do round up, even though it's comma 2. Okay. The 1,25 is the 1 whole. Yes, Robert, that's right. 1 1/4 is 1,25. Okay, you can check that on your calculator. If you get to the exam and they give you funny fractions, all right, careful, we need to do mixed fractions here. So there's the mixed fraction button. You see this button here? That's the little orange part on the top. That's the mixed fraction button. All right, don't do 1 and then press the fraction, like 1 and then don't do this. Don't go in front of this now and then do that. Okay. Don't do that. That's 1 times 1/4 according to the calculator. You need to use the mixed fraction button. So that's shift fraction. There, that is the mixed fraction button. That's 1 1/4. Okay. 1 1/4, and that equals 1,25. You can put this in your formula. Watch, I'll do it. Let's try it out. So 25 times. I'm going to do it maybe like you guys would do it. So I'm going to say 1/4. Let's see if this works out actually. And I'm going to put the 1 in front. So I'm not using the mixed fraction button here. I'm just using the normal fraction button here. Let's see if this works out. Ah, you see that? 6,25, which is wrong. So be careful with your fractions. You must press the mixed fraction button. All right. So if you don't want to change it to decimal, use the mixed fraction button. Shift fraction gives you that. Then you can put in 1/4 like that. That is 1 1/4. That will give you 32,25. Sorry, 31,25. Be careful of mixed fractions. It's easier to change them to decimals. Okay. All right. Be careful of that. Did you guys all see that? I hope you did. All right. Stop me at any time, guys, if you need me to explain again. We're moving on to the next question. Here comes the finance. All right, I'll show the question and then I'll show you exactly how to do it. So here comes the finance. If cement costs 57 Rand 50 a bag, stone costs 25 Rand 20 a barrow, and sand costs 13 Rand 75 a barrow, determine the total cost for the concrete for the slab. All right, while you guys are working on that, I'll explain this button again. Okay, so if they give you 1 1/4, and look at my calculator here, I'm deleting this quickly. Sometimes what guys do is they don't use the mixed fraction button. You see this normal fraction button. They click on that and they say, put in 1/4 and then move to the front of it and put in a 1. Now, if you look at that, it looks like 1 1/4, doesn't it? But the calculator reads that as 1 times 1/4. Okay. So when I press equals here, it gives me 6,25. All right, which is not right. So what you need to do is type in your mixed fractions like this. Okay, there's a button. Whoopsie. Above the fraction button, you see there that orange part. That's the one I want. So I'm going to press shift fraction. That's the mixed fraction button. Now you can put in your numbers, 1 1/4. Okay, and that gives me 31,25, which is correct. All right. Okay, I hope that helps. Yo, from Lele's typed it all out. Oh my gosh. You guys have got quick fingers. Sure. So it's gonna cost almost 2.5 grand to make the slab. Yo, making slabs is expensive. All right, we got some answers coming in. I'm going to wait a little while so you guys have a chance to try yourself. Try this on your own. All the things you need are there, except for the bags of cement here. Hey, well. I'll just write it down here if you guys can't see. So 25 cement. We got 32 of sand and 32 of stone. Okay, Tando, you see when it says in the question, if cement costs 57.50 per bag, we have 25 bags. All right. So you need to do 57.50 times the number of bags that you have, plus 25.20 times the number of wheelbarrows of sand, plus 13.75 times the number of wheelbarrows of stone. So it's price times the number plus price times the number plus price times the number. Okay. All right. One more minute and then we're going to try this one. All right. Yo, it's a big number, eh? Okay, let's have a look. It's 57.50 per bag of cement. 57.50 per bag of cement. How many bags we got? We got 25 bags. Okay. All right. For sand, it's 25, sorry, yeah, 25.20 for sand per wheelbarrow. And I have 32 wheelbarrows. For stone, it's 13.75 per wheelbarrow. And I have 32 wheelbarrows. All right. I need to add these all up. You know me, I like brackets. Forgive me. All right, we need to add those all up. Okay, there we go. All right, let's do it on the calculator. Forgive me for brackets, but I like to use it. 57.5 times 25 plus 25.2 times 32 plus 13.75 times 32. All right, let's check it out, ladies and gentlemen. 2683,9. 2683,9 rands for this concrete slab. Yes, or that's fine. You can also do it like that. So, or you can also work out how much for all the cement, then work out how much for all the sand, then work out how much for all the stone, get 3 values, and then add those 3 up. I'm doing everything in one line, one shot. Okay. So I've done all the calculations in one line, but you can work each one out and then add your answers up. Absolutely fine. Nothing wrong with that. All right. Good. Looks like we're on the right track. Is there more? Yeesh. Yeah. I'm going to take a break. I'm not going to do this last part. I want to go up to this hard question. We're going to take a quick break while you guys look at this. All right, quick break, and then we're going to carry on. Oh, you have to all admit that week 3 is better than week 2. Hey? Week 3 of school is definitely better than week 2. I'm feeling much better in week 3 than week 2. I know we spoke about this already, but why? Why is that? Who can tell me why is week 3 easier than week 2? No, it won't be wrong. You should put rands there. All right. And you don't have to put the 0 after the 9, but you should put rands there at least. Okay. Show your units with the rand sign. Guys, who can tell me why is week 3 easier than week 2 of school? Can anyone tell me out there? I don't understand, but we said week 2 definitely feels hard. Kia, I don't know about you, but week 3 feels better than week 2.
I think it's because you're starting to get used to it again.
Yeah, the routine.
Yeah.
Yeah, I think it's the
So I
routine.
came back from like a life of relaxation and now I'm like back to work, everything. So now I'm getting used to it again.
Yeah, I think Kagiso's also going to answer here as well. Why is week 3 easier than week 2, Kagiso?
No, Pumelelo says it's because it has finance. Agreed.
I think it's also because you already told yourself that the first time you didn't understand, but now you do. And the fact that you do, you always want to understand, like just like every time. Because week 2, everybody was just trying to adapt, getting to know it. Like every time now you know that they're going to remind you that no, at 6 o'clock you have to be with Watobe. So that time it's like, oh, I have to do this, I have to do that. But now you're like, oh, okay, you
You get,
adapt.
you get used to it. Yeah, you adapt and get used to
Yeah.
it. Resilience. That's a word for that. We are more resilient by week 3.
And consistency.
And consistency. So we're consistent and more resilient. What's this here? Neo says just started holiday at last.
Yeah.
Oh,
That's one great. That's one the grade 10 maybe.
Neo, which school are you from that you just started your holiday? Neo, which school are you from that you just started your holiday? Aibo.
Sorry,
Someone else.
sorry.
Neo,
Neo,
can
just check your screen again.
check your screen there, Neo.
Oh,
Neo,
so
you
I'm in
there?
Eagle House.
Ah.
Yes.
So so are you saying you started your holiday for the end of term 2?
Term 2, yeah. We only started this week.
So you had how long? Your term 2 must have been very long, eh?
Yeah, it was. But our holidays are also long, so it's fine.
How long is
How
your
long
holiday?
is long? Yes, how long
We
is long?
started this week and we're going back to school on the 3rd of September.
Oof.
Ah,
Wow.
where's the
Don't
school
think-
again?
Yeah.
It's in like Gramsach, Eagle House.
Eagle House.
Yeah.
I live close to Remsag. Are they looking for a teacher maybe?
Oh, for sure, maybe.
Yo, see, everyone's like, I'm coming there. Bianca's like, where? I'm coming. We're coming, guys. We're packing up. We're going to that school. Hey?
Yeah, I mean, a whole
Yo.
month of not having to walk around in dust. Sign me up.
Yeah, that sounds fantastic. Oh my gosh. Jeepers. Thank you. Nia, thank you so much for that. All
Thank
right.
you.
Okay, guys, we've got one more question left. It's a challenge. The struggle is real. All right, I hope you're ready for this one. I hope you're ready for this one. The struggle is real. All right, I'm going to read it. It says, swimming pools come in many different shapes and sizes. A homeowner wants to place a swimming pool in the garden. The homeowner decides on the following pool design. Just remember that the drawing's not to scale. So on the top there, we have a side view, all right, of the pool. We can see how deep it is and how shallow it is. Underneath, we have a top view. We can see it's a rectangular shaped pool from the top. So the top diagram is a side view, and the bottom one is from the top of the pool. Okay. I hope you can understand. Bianca's like, that's it, I'm done. This is why I did this one last, Bianca, so you could do some work first before you leave. Okay, but this is the question. Calculate the volume of the pool. Oh gosh. Can you calculate the volume of this pool? There's no, and I know you're thinking, so where's the formula? Show me the formula, I can work it out. No, there's no formula. There's no formula. In fact, I don't even think we should try. Would you guys like to try this? I don't even think we should try, guys. Ben, I knew Ben would say yes. Bianca is back and she's trying. All right, I'll give you some time. Shiana was like, never. Never. All right, try. There's no formula. Can you do it without a formula? Can you do it? This is the last capacity volume question from me. Respectfully, or it says respectfully, nah. All right, try it. Try it. There are the dimensions. What's the volume of this pool? Oh, I'm nervous. Yes, Tando, you're on the right track. Length times breadth times height is for rectangular prisms. There are some rectangular prisms in here, but that's not the only prism. It's not the only prism. There are some rectangular prisms, but it's not the only prism. Guys, try it out. Give you a good couple of minutes. Let's see what you can do. Let's see what you're made of. After everything we've come through for 3 weeks, there's no formula, so you're not used to that. But let's see what you can do. It's all about shapes. What shapes do you see? This one's a cracker. I've got my own little emoji here, but the struggle is real. There's a lot going on here, yes. Kumlela, there's a lot going on here. Let's see what you can do. I believe in you. Ten, 5 times 1,8 times 1,2. 10,5 times 1,8. So that'll get you close. Sure, that'll get you close. If it was a rectangular prism, it would be easy. Just length times breadth times height, but it's not a rectangular prism. There's a few shapes. I'm going to give you a clue. There's a few prisms in here. You're going to have to pull this thing up. I'm not going to give. Oh. Let's see what you can do. Let's see what you guys can do. Yeah. Katlejo, this question is not my sure. I have to agree with you, but there's some people out there that I know that can tackle this one. Let's see what you can do. We've got a lot of people saying 22,68. All right. All right, let me delete this diagram because I think people out there can actually do this. Let's see. All right. For those of you that are trying, go up a bit, please. I don't think there's any information further up. No, nothing further up that we need. Everything is in the diagrams. Everything's in the diagrams. All right, you guys carry on, and I'm going to try walk through this. We've got a lot of shapes here. Okay, so what I'm going to do is I'm going to split this up. We're going to draw a line here. Okay, that'll give us a rectangular prism over there. All right, which is this one here. All right, there's the top of it there. So it's dividing it. Then what we're going to do is we're going to put a line here to cut this one up. All right, so we've got one shape here that's a rectangular prism. There's another shape there, number 2, which is a rectangular prism. The problem is in the middle. So what I suggest you do is to split the middle up into 2 shapes. Number 3 is a rectangular prism, but number 4 is a triangular prism. So there's 4 prisms here. Okay, so what I'm going to do, let's say volume of the first one, which is a rectangular prism, which is length times breadth times height. Okay, I'm going to say the length is 4. I'm going to quickly do this before we close. So length is 4 times the breadth is 3 times the height is 1,8. Don't shout at me because I'm putting the numbers in the wrong place. It doesn't matter. Okay. And then for number 2, we got a length. I'm going to say it's also 4 and then the breadth is 4, and the height is 1,2. All right. For the volume of the third rectangular prism, that is also 4. The breadth is 3,5, and the height is also 1,2. Okay. The last one is a triangular prism. All right. Which means we need half times the base of this triangle. I'm going to say is this little piece here. I'm sorry. My apologies. It's this little piece here, okay, which is 1,8 minus 1,2. This is this top piece here is 1,8, sorry, 1,2, and this big one is 1,8, so it's 1,8 minus 1,2. All right, so I'm going to put that in there in a bracket, 1,8 minus 1,2 for that side of the triangle. And the height that I'm going to use is this one here. All right, doesn't matter which one you use. Okay. So that's the base. This is the height, which is 3,5. And then I'm going to multiply by 4 at the end. So those are the volumes of all the triangle, the prisms there. Okay. You would have to calculate all of them and add them all up. Okay. So this is why we didn't get a formula for this, because the formula would look absolutely, no, we don't need a hypotenuse. Okay. So because we've got a right angle triangle. All right, we've got a right angle triangle here. You can have this as your base and this as your height, and then multiply by the length of the triangular prism. So on my diagram over here, this could be your base, this could be your perpendicular height, and then this is your other height. Okay, so don't worry too much about this, guys. Ben, you did this in class today. Fantastic. So you work out, you cut it up into different prisms, work out the volume of each prism, and then you add them all up. Okay, so if you get something like this, and they don't give you a formula, but they should give you a formula. You cut it up into pieces, into chunks, work out the volume of each one, and then you add them all up. But don't stress about this question, all right? It's a tough one.